Like many good mysteries, this one leads us to a graveyard in our search for clues. In Vienna, near the final resting places of Beethoven, Brahms, Schubert, and Strauss, is 19th century Austrian physicist Ludwig Boltzmann's tombstone. Etched on top is an elegant equation, S equals K log W. It's the mathematical formulation of a powerful concept known as entropy. Entropy is a measure of something that we're all familiar with, disorder or randomness. And it's an important idea because there's a tendency of everything in the universe to move from order to disorder. Here's a way to get a feel for the idea. Take my book, all 569 pages of it. It's very ordered, with the first page followed by the second, followed by the third, and so on. But now, let's tear the pages out and let entropy go to work. As you can see, the pages become very disordered. And the reason is simple. There is only one way for them to land in order, but a huge number of ways for them to land out of order. And so it's much more likely that they'll land in a total mess. And this is what we experience in our daily lives. Things move from order to disorder. In this case, from a neat ordered book to pages that are randomly scattered. Everywhere we look, we see examples of entropy or disorder increasing with the passage of time. An egg breaks and splatters. Ice cubes lose their orderly shape as they melt into water. Billowing smoke becomes increasingly disordered.
Ordered states become disordered states. And that appears to be perhaps the direction of an arrow of time.
We see sort of degrees of messiness, a measure of disorder, tend to increase in one direction of time.
And so that, for Boltzmann, begins to create an arc of time.
So maybe this is the answer. Maybe the arrow of time comes from the tendency of nature to evolve toward ever greater disorder. This sure seems like progress, but there's just one small problem with this reasoning. Because the laws of physics don't distinguish between the future and the past, entropy should increase not only toward the future, but also toward the past. And that makes no sense.
That's like saying that entropy should increase in either direction that we look. We could look backwards in time and it should increase. We could look forwards in time and it should increase.
That would mean the pages of my book in the past would be disordered and then come together to form the neat ordered book in my hands. And when's the last time you saw something like that happen? How could our everyday experience be so at odds with the laws of physics? There must be a piece of the puzzle that's missing. If we're sure the past had to be more ordered, and that everything tends toward disorder as the equations of entropy tell us, is there something else besides the laws of physics that might explain this? Well, think of hitting a baseball. The laws of physics can help you predict where it will land. But those laws are not the only things you need. Run the film backwards, and you can see that you also need the initial conditions, like how hard the ball was hit. Similarly, if the laws of physics can't give us an explanation for the arrow of time, maybe we need to look further to the initial conditions of the universe. That brings our attention back to the Big Bang. If the history of the universe were like a movie, and you ran it backwards, you'd see an increase in order the further back in time you go. Gradually, today's universe, with billions of galaxies clumped here and there, would turn back into clouds of gas and dust as everything contracts.
So these clouds of gas and dust move closer and closer to each other, so that if you get far enough into the past, they're squeezed into a smaller and smaller volume.
We've now come to the place where the buck finally stops. If this represents all of space at each moment of time, then we can see there simply isn't any more space and time before this single moment. So the ultimate source of order, of low entropy, must be the very beginning of the universe, the Big Bang.
The Big Bang is a highly ordered state. It's probably the most ordered event in all of physics. And so everything that has come after that has been an increase in disorder.
What the Big Bang gives us is a reason why the universe might look different when we look backwards in time versus forward. Moreover, when we go back to early times, the universe should have looked not just different from today, but highly ordered.
Why was the entropy low? We don't know. But at least we know that there was a point that the universe began in when the entropy was low.
So our best understanding is that the Big Bang is what set the arrow of time on its path. You can picture this as something like a wind-up clock. Just as the stored energy of a tightly wound clock is released as it unwinds, the universe has been unwinding since the Big Bang, becoming ever more disordered.
Our universe started out in a very unusually orderly state. And that's ultimately responsible for the fact that time seems to have a direction.
We don't yet know why our universe began in a highly ordered state.